So firstly we're going to look at talking about aircraft carriers is some views on stopping and of cable arresting planes. This is early days, as you can see. Some of you I'm sure will recognise that type of plane as well. No problem. The Wildcat or the Mark. This is an interesting one too. Have a look at the safety net on this particular aeroplane. This plane is very full mark, but you'll notice the safety would sort of just almost catch it by the undercarriage, the wheels rather than anything else. This was on the old Ark Royal, by the way, going back all that time to World War II. Here we have the first carrier jet landing.
In December 1945, a jet manages to land on a carrier for the first time. It is an extraordinary feat of flying by Winkle Brown, the Royal Navy's top test pilot.
If you don't know much about Winkle Brown, it's a good thing to find out a lot about him. He's the most amazing test pilot and got involved in very crazy things. The only thing I don't know about, when he landed as Vampire there on HMS Ocean in 1945, I don't know whether that was really the correct Sea Vampire that came later, or was this especially just a modified Vampire just to do this with. I don't know the answer to that one.
It's an ordinary Vampire.
Ordinary Vampire, thank you. But with an arrestor hook?
Sorry?
With an arrestor hook?
No, they put one on.
This is just another view, another carrier landing. And now this particular picture's got a very interesting history in the Royal Australian Navy. It's landing on HMAS Melbourne. You can see they've actually got the barrier net up, and it's called the barrier net. This particular aeroplane, if you want to go and see it, they might have moved it around, but it was in a museum in a place called Narellan, which is near Camden in New South Wales, and it never flew again. That's that plane touching down for the last time. There are two accounts in the book of the Australian Fleet Air Arm about what happened here, but the pilot took off, and as you know, that aeroplane, the Fairey Gannet, has actually got two engines called the double Mamba engine. And what happened straight after takeoff, the one engine failed, and the pilot had to make a decision quite quickly, and the aircraft had rockets, loaded down with rockets for an air exercise where it's going to fire all these rockets off. And the pilot then elected straight away to fire the rockets, all the rockets, to reduce the weight. And on doing that, the takeoff flaps were still down. And have any of you heard the story before? Do you? No, okay. Anyway, he fired off all the rockets, and the flaps were destroyed. So he had an issue there. And I don't know anything about the systems of the Gannet as such, but you can see that one has not gotten the arrestor hook down. Came around and it landed without the hook, and it went into the barrier, which of course caught it, which was good. We won't go into too much detail on this, but there are different ways of actually retarding the aircraft. This is the one way. They have a cable sheave system at the top. You can see it at the top with two end pieces that get pulled towards one another as the aeroplane gets arrested, and the water goes through and it goes into a hydraulic accumulator which slows it up. What is interesting about the British aircraft compared to the American aircraft is that the British, with their earlier, with their earlier arresting systems, they tried to stop the plane with the minimum amount of deceleration, and there was no sudden jolt when the aeroplane slowed up, because a lot of the British aircraft were actually derivatives of land-based aircraft, whereas the Americans, with the Grumman Company and these people, they tried to pull the plane up as quick as they could because they knew the structures could take it. But later, of course, the British have turned around again and they've got another system. Here you are. This is another system where they have it. They had two long tubes down the whole length of the aircraft, British system again. And what happened was it pulled the piston pulled water out of the tubes and slowed down the plane in that fashion. This is really quite up to date. You haven't heard of a company called General Atomics? Well, General Atomics is what they call an advanced arresting gear. And this is used on the new aircraft carrier, which is called the General R. Ford. I'll tell you a whole lot of things about the General R. Ford. And I wrote to this General Atomics and I told them, look, I want some decent sized pictures, please. I'm going to give a talk to somebody. And anyway, they never replied to me, and they've got a couple of problems, this General Atomics. By the way, General Atomics, they make these lethal drones, by the way, that they fly in Afghanistan and these places. Anyway, basically, the system basically is, seems to have two things that are like churn up water in them, and they've got a motor that controls it electronically. Now that's the good news about it. The bad news is they've only tried this on land up to now, rather than on a ship, and they've done hundreds of arresting of the FA-18 type planes, and that sounds all right. The trouble is they've had to repair it every time, and so I don't know where the status is now of these, but it is a source of worry. Just we know about the actual lights they use, so the pilot can set himself up for landing with the aircraft on the carrier. There are two particular systems. One's called a mirror array, and the other one is called the Fresnel lens system. These were developed by the British originally. Bringing it up to date, this is the FA-18, just to show you what the hook looks like. The United States Navy's got very, very complicated procedures compared to civil aviation as to how you put your plane down on the deck, join the circuit and all that sort of thing. It's a completely more complicated system. Okay, you can see this one is just catching the cable. One thing is, ask yourself, that cable can't lie on the deck, can it?
No.
No, it's got to be a certain height above the deck so that the cable hook can snag it underneath. And you can see, we'll see it in other pictures as well, it's got a thing called bow springs. You can see a couple of springs there, and they're the thing that actually keep the cable off the deck. Royal Australian Navy, Skyhawk, of course, another one of the Skyhawk, and that's showing you the deck, and the Joint Strike Fighter, the carrier version, that's showing you the actual hook of the Joint Strike Fighter. That's the C model. And that cable must be quite heavy. Look at those fellows all carrying the cable around. It must be a pretty heavy thing. That's on a cable change. And what you might appreciate with these actual crash barriers, the new carriers, they've got things called angled decks. So in other words, you could be launching aircraft away from the landing deck, and you could be servicing aircraft there. The old ones weren't like that. They just had a straight deck. So you had to protect the personnel on the aircraft that were down the other end of the ship, because if you didn't catch a cable, you'd be going into those other aircraft. But they still have to have crash barriers, because you could have an aircraft coming around and it's got some hydraulic problem of some kind or something like that without the hook. So they still have to be able to catch an aircraft when things go badly. And why not do that on the ground as well? They have locations where Air Force fighters have to actually use these arrestor gear as well. You'll notice they haven't got the bowstring over there. It looks like a kind of plastic ball or something they're using at the end. You can appreciate that aircraft takeoff performance, so that the plane can pick up a bigger weight, provided it can stop effectively. Because if the brakes aren't big enough, or the way of stopping the plane aren't big enough, then you've got to reduce your weight on the plane accordingly when it takes off. But that's a bit beyond us. We don't have to talk about that in any great extent today. Just different brakes. That's like a modern brake assembly. This is on the 737 NG model. They've taken the wheel off. You can see the segments. These segments rotate. Half of them are keyed onto the actual axle, and the other half they key into the actual wheel. That's just another view of that. There's a lot you can actually know about these new brakes. They're carbon ceramic. They started using them on Concorde. And have any of you flown recently or not so recently and noticed that they don't use the thrust reversers often? Any of you seen that on a big plane? Yeah. Well, obviously it keeps noise down in the middle of the night, but But the brakes are so more effective today that they don't use thrust reversers all the time. And sometimes, like on the big Airbus, they only have thrust reversers on the inboard engines, for instance. This is just a section view of more of the same again. Another section view of the brake assembly again. You can clearly see the lugs that go onto the wheel. Of course, this is all outside, what you see outside here, single disc brake on Cessna light aircraft. And what happens when brakes overheat? The flight crew want to know how hot the brakes are, and they've got ways of actually checking out on this. And they actually have things called fusible plugs. The actual rim has got a steel plug in it, but in the middle of it they have a low temperature solder. And if the brakes eventually get too hot, then they deflate the tyre, because there's nothing worse that could happen with a big aircraft if they retracted the gear and you had a tyre just about ready to burst. If you look at the undercarriage well in an aeroplane, they've got all kinds of hydraulics and things there, and that could be catastrophic. So they'd rather have the tyre being deflated. A man I worked with told me a story one night that when these aircraft do lots of touch and goes when they're training, the brakes get quite hot. And anyway, and he got a call from the hangar and said to the hangar, saying, I think you better come out and change some of the tyres. The landing was a little bit rough. And this person, he said, okay, well, I'll take 2 wheels with me. And he went out there, and the landing was rough because all 8 wheels were deflated. This is just, again, the equipment they have on various planes to show the temperature. This is the park brake, and the park brake often hasn't got anything to do with actually emergency brake, and that you can run into trouble if you don't know when you can use the park brake or not. So these aircraft have what they call auto brake and anti-skid system. You can have it on different settings. The abbreviation RTO, rejected takeoff. That's the most severe form of braking you could get. And what's very interesting, Boeing have got a new aircraft, the new 777. And as you know, these aircraft have got auto land and auto brake facility and all that. Well, computers have got so smart that on the 777, the computer gets told what runway you're going to be landing on at that particular airport, and it knows where the taxiways are. And you select what taxiway you want. And the plane lands, and the auto brakes you just enough so you can turn off on that taxiway you've selected. So what's next? Okay, this is just a schematic of some of the auto brake system, and this is really going back in history now. These are the very first anti-skid systems they had. It was something called Maxaret, and it was a complete mechanical type of a kinetic device, so that you couldn't skid your wheels on the plane, and they were used on quite high performance planes as well. The English Electric Lightning Fighter had it on, the Canberra had it on, and VC-10 and Super VC-10, they all had this Maxaret system. But of course in today's world, guess what? It's all electronic now. And there you are, there's a plug for the RAAF Museum. If you come and visit us at the museum, look at the Canberra, because that's the one that's fitted on the Canberra. Now these are the more simple ones that some of us know from our motor mechanics, the drum and the shoe type brake. This is now where you have the shoes expanding radially outwards. Earlier aircraft they used to use compressed air as well, but or other ones use hydraulic fluid, of course. Also from the RAAF Museum, this is from a Liberator bomber, main undercarriage on the Liberator bomber. How do we slow up a plane with parachutes? First use of parachutes for braking was in 1912, and unfortunately it wasn't an aeroplane, but it was used by a person to brake a motor car. So even in 1912 they could get a car going fast enough, they'd have to think about how they're going to slow the thing down. And this kind of motor car, for those who follow motor cars, which I've never heard of, is called a Russo Bolt motor car. and he opened a parachute attached to the back seat. And that, of course, the last one you saw there, that was a B-52 bomber, which was landing somewhere. It's interesting that where bombers used parachutes. Some of you I know are from the UK. I've had one person from the UK tell me this, but they used to, the B-47, which was a big six-jet bomber, they would actually extend the parachute before they landed. And you can see pictures of the thing landing with the parachute out. Anybody seen that? Yeah, they did that. And interesting enough, even an aircraft like an executive jet like a Cessna Citation, the early Cessna Citation which I worked on, they actually had an emergency parachute. The parachute wasn't intended for deployment under normal day-to-day conditions, but if things got difficult you could actually deploy the parachute. I don't have another little plane that had that. Here you can see this Mirage, it's French Mirage. You can see the parachute is in the process of opening up. And more up to date, this is the Eurofighter, and this is landing at an air show in Fairford in the United Kingdom. You'll recognise that aircraft. SR-71. This particular aircraft, they're not actually packing the parachute there. This parachute comes off a MiG-29 fighter. That's not a MiG-29 fighter in the background, by the way, but you're just rolling it up, and presumably they go and pack that thing somewhere else. Okay, now how do we stop the plane in the air and on the ground aerodynamically? Bigger airliners, they have what they call flight spoilers and ground spoilers. The spoilers that are called the flight spoilers, they actually slow up the plane in flight. They can also help to turn the plane. They've got a coordination that fits in with the ailerons. So the spoilers operate with the ailerons, and depending how much spoiler you've selected, that's the amount of spoiler you get. The ground spoilers only operate once the aircraft's on the ground. How do they make sure they only operate when they're on the ground? Well, they have limit switches on the undercarriage, and once they see, like on a 747, maybe 3 out of the 4 bogies are actually on the ground, then the ground spoilers will work. That's the spoiler lever there, looking from if you were in the pilot's seat, and the first position they have on that particular lever is armed. So with it in the armed position, the moment the aircraft is properly on the ground, that's when you'll get all your spoilers. And sorry, first you have the flights in the air, and then you can have full spoilers selected as well. Those are just the flight spoilers coming up there now. And that's on a 727. That's what some people call 40 degrees of wing disassembly, Boeing, where you have the flaps pulled down, you've got the spoilers all up, and you can see the ground all around the wing. That's an Airbus. We've got to give Airbus a bit of a promo too. So that's on an A320 Airbus. Now this is interesting, a DC-7B, Douglas DC-7B, and how they had a dive brake for that thing in case they had to do emergency descent. You could actually extend only the main undercarriage. Keep the nose gear in, but the main undercarriage is strong enough for you to put the nose down and build up a lot of aerodynamic pressure on the thing. Also used on other aeroplanes too, by the way, as you see there, and also on the Trident. So I don't know, there might have been other aeroplanes that also use that feature. There you can see the speed brake there on this FA-18. You can see the big speed brake on the top of the fuselage. This is now another feature which is quite a good type of speed brake, where you have this split cone at the back of the aircraft. And that's perfect because it keeps the plane going in a straight line, doesn't it? You're actually retarding it down the centre line, which is pretty good stuff. A couple more views of that one on the Buccaneer. By the way, I'll tell you something about the Buccaneer. It was an extremely strong aircraft from a structural point of view. It was intended to fly very fast and very low. It was very strong. And that's on the British Airbus 146, which you still see flying around here. I see them over my house every now and again. And the whole story of the thrust reverse, a story in itself. You could retard the aeroplane 2 ways with thrust reverse. You could work off the main hot jet stream or the fan section in the front, or both. So the older aircraft actually had both. The original 747 actually had the hot gas reverse system as well. Of course, for those who are not familiar with thrust reverse, the engine always keeps on running in the same direction. There's no magic tricks going on inside the engine. It's what you're doing with the air that's leaving the engine or going around the engine. That's the views of the actual thrust reverser, the rear thrust reverser, and these were worked by means of the aircraft pneumatic system, bleed air coming off somewhere off the engines. Very light structures, by the way. You'll see a picture just now which you'll understand. They're very, very flimsy structures, these thrust reversers. They're trying to keep weight down all the time on these things. This is one view just showing the fan thrust reverser, which is the front one. And why they use that extensively today is because they have what they call a very high bypass ratio, so that it's okay to actually reverse the front air, even though you've increased thrust and you've actually increased power on the engine, and you've got the jet stream, the hot jet stream wanting to push it forward, but the fan is so much more effective that that's sufficient in itself. That's just another view. You've got these things called blocking doors and so on, and they go around circumferentially around there. You can see the top right-hand picture with a green thing on that. That shows you where the doors are blocking and they having the air going forward. The round figure on some engines, you can get up to about 40% of the power on the engine with thrust reverse. They don't use thrust reverse all the way down to very low speeds on the ground. Anybody know why? You get something called ingestion. The air from, if you've got two engines next to one another at very low speeds, you get the air coming out of the one engine and being ingested into the one next door, which causes instability. That's now the forward thrust reverser section. You'll see in a couple of pictures. That's what it looks like. This one's got multiple cylinders. It's got, I don't know how many cylinders now, 14 cylinders or something, all those things that say no step. They're all the cylinders that move this sleeve. It's called a sleeve. Around that sleeve is that piece of vertical metal right in the middle. So it moves the sleeve, and that in turn moves these blocker doors. And another view of the same. Those are all the blocker doors. You can see the one that's got number L4 on it and so on. Those are all the blocker doors around the thing. This is again just a schematic, just to tell you very briefly that these thrust reversers, they are controlled by the pilot in this case. There's no automatic sequencing that says, okay, if one thrust reverser is not working, I'm not going to give you another thrust reverser on the other side or anything like that. It's very much at the pilot's discretion as to how he uses the thrust reversers. Only on the ground for a lot of aircraft, but some still in the air as well. The Jumbo 747 was different again, in that it had an air motor at the top of the cowling called the pneumatic power package there. And this air motor would then, through this green cable, it would actually move the sleeve back and forwards. This is what the actual power levers look like inside the plane and in the cockpit, and the actual thrust reverse levers, those are those three levers more on the right hand side where the pilot actually grabs them and he pulls them up. Two levers, sorry, and so gets the thrust reverse effect. Got a few pictures on the 727. I don't know which particular engine this thing had in. Just showing you something about it. And you see the thrust reverser has a big set of doors here. Clamshell or target doors, they just close up behind. And this next one is very interesting because for some inexplicable reason there's hardly any ground clearance there at all. I don't know, I can say maybe the tyres needed pumping up or the oleos needed more pumping up. I don't know. This is an interesting thing, and maybe somebody at the end of the presentation can help me with this. With this, the 737, there's so many different models. And the one I read that said that you could actually use thrust reverse in flight, provided the aeroplane on the radar altimeter was no more than 18 feet off the ground. But that plane with that thrust reverser there, he's got a long way to go to the ground. But help me out if anybody knows that one. Oh yeah, this is something else. Well, you know, if you get tired of waiting for the tug at the gate and the tug doesn't come, well, why don't you just deploy the thrust reversers at the gate and back away from the terminal building? And this is what this aircraft has done. There's only one thing about it, you've got to be very careful. Don't put your foot on the brakes. There you are, that's on the Airbus again, A320 Airbus, and that's on an executive jet, and you can see that the two doors are moving to the back for the thrust reverse to operate. Now, one of the very first aircraft that was allowed to use the thrust reverse in flight, big aircraft, was the DC-8. Thrust reverse is all that flimsy sheet metal stuff at the back there. I haven't got a picture of it actually in the thrust reverse mode, but what you'll see is that you get serious heat on those things, just even using normal takeoff power. See the way the things are glowing red hot, white hot maybe. Okay, I'll go through this very, very briefly. Reverse pitch, a lot of the propeller planes, so you could actually select the propellers to go through from, first of all, ground fine pitch, they could go through to reverse, could open up the engine power, and you would start and stop quicker, showing you the positions, the angles that are involved, again there as well. Now, other stopping methods. Apparently there was more than one aircraft, but this is the Bandeirante, which they used to fly out of Perth, by the way. The Bandeirante being made in Brazil, I don't know whether they got anything wrong with their airstrips or things there, but they thought it was necessary that these aircraft could actually stop by making a wheels-up landing. So you had a switch you could select, wired-off switch, you could select up, and you could actually land the thing wheels up in some kind of jungle clearing or something like that. Those RAAF model vampires also had this feature. Okay, that's when all else fails. You can get a system if you have the luxury of the space on the airport, where you can actually have the overshoot, and it's made out of a special material, and it can stop the plane pretty quick smart by actually the material actually fragmenting and collapsing. And that's about the same as you have when you go down from the hills. I've got these runoff. This is interesting now. These were used by the Germans, and these particular aircraft, the DFS 230, that had a parabrake on it where you could do very steep descents. And they also, you'll see on the next thing, they also fitted retro rockets in the nose. And using the parabrake and the descending, you could actually stop the aircraft in less than the length of the fuselage. These things took about 16 troops, and you could do that. And the next picture will show you that. Shows you this technician busy loading up all the retro rockets in the nose. And that's actually a picture of it landing. You can see that the parachute's at the back, and you can see the rocket is fired at the front. And the rockets actually had a second stage, and the second stage wasn't so much for retarding the plane, it was to create a smoke screen so that people could charge out of the glider without being shot at. That I don't believe was ever used as such, but anyway, we know what that is. Harrier, I've got to put it in because yes, that thing could dance around in the sky, I could go forward and backwards and left and right and all that. That definitely qualifies. And other stopping methods, I thought of a whole few of them, there might be some others, let me know if I've missed out on any. That third one from the top, I've seen it in movies, maybe you have seen it as well, but where the bomber crews, the good old B-17 would come back with all its hydraulics shot out, and the crew would use their parachutes that tied onto something and through the waist gun positions at the back and slow up the plane using their personnel parachutes. I don't know whether they've ever done, or it's only just something in the movies. Mm-hmm. Are we going to stop? And yeah, that one's not going to stop.
It was brand new.
Even got a smile on its face.